All right, class. So today we are going to be starting our project with array. Technically, we started yesterday, but we used yesterday's session to build our environment. And today we're going to be heavily focusing on the practical aspect of the project. So this project will give you a broad knowledge on how you can automate using the GitLab CRCD pipeline, involving Terraform, involving version control system. That is, you going through the route of repository, checking in your code, and then deploying, right? So this project going to open up your mind, and you will be accountable tomorrow to use this project as one of your real-time projects in DevOps. So having said that, we're going to deep dive into the project. This project involves you leveraging GitLab, you leveraging Terraform, you leveraging AWS, you leveraging Git, and the version control system, and also branching strategy as well. So there are a lot of things combined to this project. Now, we are considered as a prospective engineers. So therefore, I will be distributing tasks to each and every one of you to do. So the first thing we're going to do is we're going to look at the code that we're going to be using. We're going to review the code. We're going to read the code. We're going to understand how the code will work, and then we're going to ask questions. All right? We're going to ask questions to understand the logic behind this, because that's the most important aspect of it. You need to understand the logic and the concept, because if you don't grab those two, you're going to be left out. So let us deep dive into this. And the first thing we're going to be looking at, our CRCD setup. All right. And after we look at the, not CRCD setup, we're going to be looking at the Terraform. And after we go through the Terraform, we're going to be looking at our CRCD setup for GitLab. All right. We are using a scripted pipeline for GitLab. It's declarative. It is declaratively positioned, but it's scripted. So that's what we're going to be using. So we're going to be reading the code and understanding the logic behind everything. So I'm going to share my screen and open my VS Code and put the Terraform code. As we finish reading through everything, detail out everything that is written in there, and then I'm going to share the code with each and every one of you. Please keep that code and modify it, because your project for DevOps engineering will also affect that as well. Please keep that code. If you get that code, save that code, and make sure that I guess many of you have your own private repository. You can check that code into your private repository to maintain it yourself. Okay? It's very important. Any question? 2 minutes for question before I share my screen. All right, I think starting at low. So let me share my screen. All right. Can you all see my screen?
Not yet.
Not yet.
Uh-oh.
Okay.
Uh-oh. You guys don't see my screen?
Now we can see.
Awesome. What can you see right now? VS Code, right?
Mm-hmm.
Okay. You can see VS Code. All right. You can see VS Code. Now, we're going to start. This is heavy, guys. Do not be intimidated. This is Terraform. I cannot help anybody responsible right now for Terraform. You understand? Because you have not started Terraform yet. The reason I did involve you into Terraform, that is yesterday going through the entire overview of Terraform, was to prepare you for this project, right? To give you the basic of Terraform. But do not get too confused, all right? Because you have not started Terraform yet. There are a lot of terms, there are a lot of things I'm going to be saying. You can ask me questions for clarity, right? But just bear in mind that you have not started Terraform yet. Okay? Now, so why did Terraform come into being in this project? The reason is very simple because we want to build our infrastructure, we want to provision our resources using the automated approach. So we want to automate using RAAC. We don't want to go in AWS to create VPC, to create load balancer, to create subnet, to create all of those things. We want to automate the process. We want to provision those resources using an automated approach, and for which we have identified as engineers a tools that we're going to be using here called Terraform. And why did we pick Terraform? Guys, this question will be asked in your interview. In your project, why did you pick Terraform over CloudFormation? Why did you pick Terraform over ARM? Why did you pick Terraform over Google's Resource Manager? Simply because Terraform has unlimited extension when it comes to APIs. Terraform is universal. Terraform deploy to any cloud environment. We did not go with AWS because CloudFormation is only restricted to AWS. And in this case, this project needed to call extensive APIs. So that was reason, or this is why in this class we are taking Terraform. And as a solution architect, you should be able to convince your clients, right? Why you ask them or why you choose S3 bucket or why you choose Terraform as a solution architect. So this is why I am telling everybody in here that we're going to be using Terraform, and we did involve in Terraform to be able to do this. So that's how Terraform came in the whole picture of this technical provisioning that we're going to be doing here. So yesterday we set up our VS Code, right? Everybody in the class now got VS Code. We install extension, right? For those of you that still did not get your terminal to work, that this color, right? The beautiful colors. Let us pick another extension. There's an extension here called, I want to go to the extension area though. View, extension. There's an extension called JSON. Bear with me 1 second, I'm looking for that extension. Okay, this is the extension. Install this extension. I mean, it's this also works with the same. It's called JSON VS Code theme. You can also install this extension too. Myself, I'm going to install this one, but there was a specific extension that we needed to use, and that extension name is not far from JSON. It's called Java. Okay. I see something called like a dark colorful, something like that, right? Dark. Okay, right here. So use this, guys. Dark and colorful theme for VS Code. Use that, all right, to get your code into that beautiful format. So you can install those two and then restart VS Code and see if that works, okay? Or if it does not work, another option I'm going to show to you here is view, and then you go for appearance. In appearance. Use those two. Use those two for now. If it does not work, I will point you to the referral one later. But use that two for now. Okay? Okay. So I'm gonna take away.
I'm trying to find the dark and colorful. I'm not seeing it.
You just go to extension and tap in that dark.
Yeah, I tapped dark. I'm on an extension right now.
Uh,
Yeah, let it tab colorful dark. Colorful dash dark.
all right. So you guys can tap that one too as well. So if you just put dark here, it will come dark and colorful. Or
Colorful dash dark. That's what it is.
yeah.
It's kind of once you install it, it takes effect.
Okay.
You just pass it to code line 13. I've got code line 13. Go all the way down.
Wherever.
No, go down to 13. Yep, right there.
Okay. Okay. All right. Yeah. So that's it, guys. Grab that and let's start. So let me remove my extension stuff from here. All right, guys. So I'm just going to reopen my VS Code. I'm going to close this one. Yeah, terminal. Got a bash and git bash. Got a CD into ABDA Cloud IC project. I will CD in this one. And then I'm going to open this and close this one. So Please focus on my screen right now. If you are already looking, that's fine, but please focus. Let's start this thing. So the first thing I'm going to be looking at is to tell you about backend.tf, right? What backend.tf is responsible for in Terraform. Why we use backend.tf in Terraform. So backend.tf in Terraform is used to manage our remote state of Terraform. Terraform has something we call current state and a desired state. When the resources that you provision in Terraform, the current state does not match with the desired state, it will be a conflict. Meaning the state management or the state file will not be accurate. So for you to manage your state in a remote location for proper locking, so that when you guys are 4-5 engineers, if Amara is running Terraform apply on the pipeline, if Frankie is running Terraform apply, if Emmanuel is running Terraform apply, what will happen? Everything cannot run at the same time. You understand? In one state. Because Terraform state file saves the blueprint of your infrastructure. So you cannot run everything as once using one state file. So there is a way that we call the remote state locking. That is the way. So what it does is that when you hit apply, meaning when your pipeline is about to apply your infrastructure, it goes in there and it locks the table using the database called DynamoDB. It creates a lock. It put a lock on it so that anybody else other than you running Terraform, it should not run for them. Unless that person running Terraform in another environment. You understand? If it's a dev environment, it is not good. The only way that can be done unless you have a multiple state files for your resources. Okay? But other than that, backend is where we manage our remote state. So how do we create this backend? Okay? How do we create this backend? If you look at the code for backend, right? Let me copy this. And then I'm going to just open a new file here. Quick, and I will just paste this code in here so we can all take a look at it. Mhm. Where is the file I just opened just now? Okay, right here. So the first thing you see in the Terraform remote state is Terraform, right? And according to your Terraform configuration, what do you call the first block when you run in Terraform? Guys, look at your note. Look at what we have discussed. What do you call the first block in Terraform? It is called what? The block type, right? So it is called the block type. So the block type for the backend we say is Terraform, because what backend are we creating? We are creating Terraform backend. Backend stores and manages the state of our Terraform file in a remote location in a secure way. That's what backend does. And then what is the block label? It's called backend. What is that resources that we're creating backend that are going to be in that backend? It's the S3 bucket. Do we know what is the S3 bucket in this class? I know you guys have not started doing cloud yet, but do you know what is the S3 bucket?
Yep.
Yeah, can you tell me the meaning?
It's a storage location in Amazon's AWS.
Storage location.
Yeah, it's an object that is used to store data.
So it is an object that is used to store data.
Yeah,
Okay,
it is.
I will take that. Is there any? So the answer to that, anybody want to fine tune it?
I can say that it's used on AWS. It's a container or storage location, like he said, on AWS.
Okay, I love that keyword I use called container. Anybody else as well? Amara, I see your hand up.
Yeah, I would say the S3 bucket is a container that, store our files. It could be anything, but it's located in our AWS remote repository, AWS cloud that stores either our file, it could be pictures, it could be anything, but it's a container.
Okay. A question to you, George and Kosi. I attempted to answer this and I did well in this, right? Is a S3 bucket based on your definitions? Is S3 bucket a persistent or static storage?
I would say static.
Who else?
Bucket. I would agree with Amara. It's a static bucket.
Kosi?
For me, I don't think that is static, it's dynamic.
Is it persistent or is static? So to you guys, George and Amara, let me correct you, right? S3 is a persistent storage. It's not a static storage. In as much it is used to store static content, right? I think that's what confusing you guys. It stores static content. Static content would be pictures. Pictures are static, right? And then static website, like a web page that just come up and then put all that information on it. That's called a static web page. But S3 bucket at itself being a storage, you understand? Being a storage is persistent. Because you guys just call it container. Why would you call something container that you say it's static? You just refer to S3 bucket being a container. And you know that anything that has to do with container always will persistent, right? So if you took this bottle, right? Let me put my camera on. All right, so guys, if you took this bottle, right, and then you put water in this bottle, and when the water reaches at the top, and it's full, right? How do you refer to that kind of storage? You unmute, Amara, if you're talking.
Yeah, I was unmuted. So bottle like that, I would say it has a limited storage. I would say it's limited.
Yeah, but how do you refer to the kind of storage being based on what we discussed in our static and persistent?
I would say static.
It is static, right? Because at that point, it reaches the point of equilibrium. It cannot go up. You cannot put anything else, like nothing else can go in there, right? So it becomes static. You understand? Because when it reaches the limit, you cannot. But when it comes to anything called container, right, it becomes persistent. It's elastic. So it will crash. It will crash. Anything you put in there, it will never fail. You understand?
So if when you say continuum, maybe the men are thinking about the Jomo.
No, the nose container. Because all my students in this class, they did Docker.
I'm sorry, guys.
So they know the container. Yeah. So think about that, right, guys? So look at this battle. And whenever anything you hear container, so let me tell you something, right? Docker span across everywhere is a runtime. Docker is a continual runtime. You understand? There is nothing that you hear about container that Docker is not in. Yes. That thing will build massively to manage persistent storage. You understand? Docker is very, very robust. Kubernetes there is nothing that Kubernetes can do to orchestrate without runtime. And the runtime having to be what? A continual runtime. So S3 bucket, the S3 bucket you see is a persistent storage. Some enterprise, I know a lot of companies, the only thing they use in AWS is called S3. And couple 2, 3, 4, 5 resources. And that company is the higher paid company in the world today. Who can guess that company if you're doing your research? With the exception, frankly.
Say that again.
Netflix, my man. Netflix.
Frankly, I said with the exception of you, I don't know you.
I thought you said I can answer. I'm sorry.
So, Netflix, like you watch, Netflix, we all use Netflix, right?
Mm-hmm.
Netflix is the higher paid when it comes to engineering in the world today. They don't joke. Netflix DevOps engineer in 700,000. Yeah, DevOps engineering range from 200, 300 to 700,000. And Netflix heavily leverage S3 bucket.
Yeah.
All the movies you see today, right? The movies you see is where the movies are stored on the release. The version of the release. S3 has something called versioning. You understand? So think about your Terraform backend, right? We say we are leveraging S3 as our backend. Why are we using S3? Because S3 having to be a storage, right? So in this case, we say we're saving our state file. What is the state file? The state file keeps your blueprint of your infrastructure. So anything that you do, that state file save it. When the state file is damaged, you screw. That's why you cannot keep state file among your files. You got to keep it in a remote location, and you got to protect it. That's what we call DynamoDB is being used for state locking. Why did we use DynamoDB? Because Terraform is by default, AWS is by default that gave us DynamoDB to enable a plastic lock to Terraform. So that when a couple of engineers running Terraform apply, they cannot result into conflict. You understand? They cannot result into conflicts. It will lock that file for you until the apply finishes. Then you open, then another person do the apply, and then lock the other one. Because we enable what we call versioning, right? So a version into different segmentation. So that's what the backend does. So how do we configure backend? How do we configure backend? We configure backend by going in AWS and creating our S3 bucket, and then taking the information to build our backend in IaaC, infrastructure as a code. That's what you see here right now. Backend is called S3, bucket name. So before when you say your backend S3, you have to create an S3 bucket. You understand? You have to create an S3 bucket. So our bucket name, what you see here, is called ABDA remote state. And I'm going to go to AWS right now and show you that. Let's go to AWS, right? Come on, guys. Okay. Let me get my password information from here. Login credential here. Okay, so, and I got a question to ask you guys too about S3. Is S3 bucket a global service? And all of those questions will come in your interview. Emmanuel, your hand is up.
Yes, it is a global service.
It is a global service.
Yeah.
What makes S3 a global service, Emmanuel? Can you tell the class?
So it's a global service because it is accessible from different locations.
It is accessible. So S3 is a global service because it's accessible from what? Different location? Manner?
Yeah, that's
Right?
what I said. It can be accessed from different locations, like in the sense that if one user is in one country,
Mhm.
then if you store something on a S3 in the S3 bucket,
Mhm.
and you make it public, that file or that object can be accessed from different places. Yeah.
Okay. Yes. So in that case, S3 is a global service, but it is also a regional service, right? Because S3 can be accessible based on regions. It's still regions data. Because if you are in an availability zones, if you are in North Virginia, right? Emmanuel, right now, which region are we in here? We are in US East 1, right? North Virginia, right?
Yeah.
So the S3 are here. It manage this region data. You understand? So it can also span, according to what you said, which I like about that, it can also span across based on configuration, right? And based on policy. It can span across to become what? Multiple region accessible, right? But by default, it is meant to store region data. Even though it is a unique service that spans globally, but it is meant to store region data. Yes. George, I see your hand up.
Yes, I was about to
Mhm.
say something about the same S3 bucket,
Yeah.
but I think you just answer my question, because if you're saying that S3 bucket is global, is a global resource, then I was going to ask, take for example, like um, the government institution, sometimes they
Mhm.
store their documents or their data on S3, and they prevent other region or other people from accessing those S3 buckets. So I was thinking that, I mean, it's a regional resource than global. But like you said, you can configure it based upon your configuration to allow it to be a global resource. But I think is regional.
Yes, so exactly. That's what I said. By default, it's regional, right? But it has what we call multi-region or multi-region endpoints or access point, right? Meaning you can configure S3 bucket according to what Eman said to become global. Because if you make it a multi-region access point, then it becomes global. But by default, S3 is local. I say local or regional, right? Now, another question again to you guys though. Is IAM a global service or regional?
Yeah, that one is the global service.
What made IAM to be a global service?
Because when you sign up for IAM, you AWS treat you as a as a global
You got it, you got it, you got it, you got it, you got it. You hit the money. That's all I wanted to know. You hit the money. IAM is span across every sector, every region. Because first of all, by default is security. Anything that is security is not regional. You understand? So IAM configuration span across multiple regions. That's why as soon you click IAM, look on there. Look at my screen, guys. As soon you say IAM, right? What happens here? If I say users, what happened? Do you still see North Virginia over there?
No, it's changed. It was changed to global.
Yeah. You see there? It changes to global. It's telling you that you can enforce policy on any resources in any region. You understand? But you cannot by default use S3 to read any data or store any data for any region in S3. It has to be configured for multi-regions access point. I hope this is making sense. Right? So that's why I thought to just ask that, because it's very important that we know so that we can know the best way to answer these things tomorrow. Okay? So let's go back to our S3. So S3 bucket. Remember, I'm going to go off camera, guys. So remember, right? What's our Terraform code for backend? Do we see this name? That name is here. This is how we created our bucket and called this bucket in our backend. Look here. So we called in that bucket you see in AWS in our backend. And this is saving all of your configuration from here in that bucket. So we call the bucket and then it saves all your configuration from here in the bucket. And who can tell me how is it able to save that configuration for all of our Terraform state in that bucket? What mechanism is it using to do that?
It's using the pipeline.
Yeah, the pipeline is being used by default, right? But what is the access that he's using? I don't want to say it, but I want somebody to say it for me. It is using something.
An API?
It is an API, but it's not just an API rather.
I would say, I would say maybe it's using our secret and access key to access our AWS account.
100%. That's it. That's the only way, right? Guys, can you reach to AWS without any, by these means, can you use a pipeline, right? Can a pipeline deploy to AWS without access key and secret key?
No.
No way. You cannot. That's the other way. So anything you see here that recording something is by the power of your configuration, what you set up. Guys, you have given so much power to this guy here. What is this guy? AM. We're going to have fun in AWS today. You are giving so much power to this guy here called Amara. Look here. Look at the power you give to Amara. You get administrator access to Amara. You get Amara Amazon EC2 full access. You get Amara S3 full access. You get VPC full access to Amara. You get GitLab Duo with Amazon premise policy access to Amara, so that Amara can deploy in GitLab. You also get IAM full access to Amara. You get IAM user change password access to Amara. You will never get it outside in the area you work until you retire. you can't do it. Nobody can give you that kind of access. Nobody, because so money the river the company is gone. So, and I'm just saying this, right? So you can know the power of IAM, right? When you grant somebody, so policy, right? Policy can be applied to what? User. And it can also what? Apply to a group. Now, a role cannot be applied to user. You apply a role to a group. Now, for instance, right? Any user, right, that inherit a role, meaning the user is part of a group. If I set up a group and I 50% and apply a policy, a rule, everything over there, every user in that group inherit that particular policy. This is exactly how we give access in enterprise or on the job, right? Because if Amara start a company today, if you start working as a DevOps engineer, nobody going to create a single user for Amara and put policy, to that user. No. We're going to apply the policy to the engineering group because the man is an engineer. So therefore, he got to be part of our engineering group. And then every access that our engineering group inherits, Amara inherit that access. If Amara leave the company tomorrow, we just go in there, LDAP, right? We run the script and go and take Amara name from there. Get Amara out of that group. Amara no longer have access to it. Even including your GitLab when you did the job, you no longer have access to that GitLab again. You have access to that, your mail profile, right? Your name, your email. You say it, but you're not seeing no company data. They web everything out. It's gone. Yeah. So that's the power of IAM. That's what IAM can do. Okay. Now let's go back to where we were. So this is our S3 bucket name. When I click here, because I ran this state, a pipeline, do you see here? I ran this pipeline. So I told you that it will copy the state of Terraform and save it in here for you. You see here? Guys, look at this. This is a Terraform state. It's keeping it in there by the work of what? The DynamoDB that will configure. You see a Terraform state? And then the good thing also about this is being enabled. We enable full versioning on this. You understand? So you see the version? Version, the amount of time you running the Terraform is getting the state, is versioning the state for you. You're giving the state a tag, a version. They said this will run, this is the version for this that will run on the 30. This is the version for this is the version for this. So that when you want to pull a certain state out, you can know exactly where to go. Say, okay, that state that I ran this was the time, I want to pull that information out. You understand? But as of today, this is the current version. So now when you see this back end, it won't be confusing to you again. Will it be confusing to you? The key that we have here, this key here, who can tell me how to locate the key in AWS? Look here, guys. We saw the key. That was the first thing we did see. So when I go back, then the number DB key, you're going to see it. So you see this. This is what? Your key, right? So you see the key. The key is where your state file is in. Because it's a key, right? When that key lock, the state file cannot be open. You understand? So when I click on the key will give me the state file because it's locked. So if you look at your Terraform code, you will see I indicate a path. I say my key will be what ABDA shop trace / and then in there you will find what Terraform.state, TF state. That's the path I'm giving. And then we all know the region, right? Encrypt, say equal to true. Use log file, we set it equal to true because it's a new way for this to work. Because at this point, Terraform introduced that the DynamoDB way cannot always work because I think it's kind of getting deprecated though. So that's why they are using this particular argument. You know, this called use log file equal to true. Hope this is clear for everybody now. When you see, well, yeah, but Terraform backend, you should, I know what Terraform backend means. You can sit on an interview and explain this with confidence, right? Yes. And the next thing we're going to go to main.tf file. Main.tf. Okay? We're going to go to main.tf file. So I'm going to go here and uncomment this. Main.tf file. What we do in main.tf file, guys. Can somebody give me the meaning of a main.tf file? Anybody?
Yeah. Okay.
Mm-hmm.
So in main.tf is where we can after declaring a variable in a variable.tf is where we're gonna put the actual resources that we are creating. It could be anything like VPC, subnet, everything. This is what we're gonna state it in the main.tf files. But we can variabilize it in a variable.tf file, and main.tf will have all of that information in a plain text instead of variables.
All right. So can you give me that answer again in the technical way?
Yeah.
Because this is the way that people will want to hear when they interview you. What you just gave to me, you give it if there is a little child in your house that don't know anything about IT or Terraform, they will understand, right? But when we give it to this class in a technical way, that answer. And it can be anybody.
Anything about it for a second. Okay, I would say main.tf, it's where we declare all of our resource that we already stated in variable.tf.
Okay. The word declare, I'm against it, but I would take the word resource is the key technical word that I'm interested in. Thank you for that. Emmanuel?
Yes, sir.
Yep.
So as the name mentioned, mean, I think it is a primary location or a primary point wherein we have configurations done. Because with this mean, you have every other thing that is inside here, like Amara said. You have VPC, you have different protocols for networking that are also in here. You are defining those protocols. So I think this is where you have all configuration and primary location for all configurations.
All right. I believe you saw my reaction, right? That is awesome. Okay. But one thing I don't want you to get used to is do not dwell on the word mean, because it's just a naming convention. Remember, yesterday I told you that thing can be apron.tf, right? Right? It can be amaro.tf. It can be emmanuel.tf. So I like the word that you use is where the actual configuration, right, happen. Our resources, our data source that we're creating, it is saved in the main.tf. Main.tf, again, guys, is just a convention in Terraform. Anything can be main. I can put my main.tf. I can say this is where I get all my main configuration here. That become a main.tf. You understand? So, yes. Thank you guys for that brilliant answer. Email, is that your old hand or your new hand?
Yeah, I got a quick question.
Yep.
So looking at because you said name, the name mean is just a naming convention. But can we also like name a file anyway, or is it based on the actual function that it will be doing? Because I'm seeing backend.tf, which is very much important. It's a name that actually describes the function of that file. So I'm kind of like, wondering whether we can just like name it anyhow. I'm aware that the extension plays an important role in .tf. But in the previous example, we have backend.tf, and this one we have main.tf. So can we just like name it and anyhow? What if we have someone who's coming in to actually take a look at maybe to continue from where we are? Wouldn't that bring some kind of confusion in their minds, like looking at the naming? Yeah.
So when I say naming convention is a naming convention, right? Meaning it's not default. You understand? Meaning, anything that is default, that means you cannot use anything else, right? You have to just use it. But you can use main.tf to represent different things. But the logic is when somebody open that file, the first thing they will see, you will put like a stuff, a notification up, right? This contain my main, configuration. So you cannot name the file anyway, but you have to name it with a name, right? That give logic to your configuration. Let's take, for instance, backend.tf, right? How you understand the word backend? Anything that backend has to be what? Okay, something that happen, backend configuration wise that happen remote. But what if I go back and say remote.tf? That's still telling you that, it is saying something about state, right? About state file and then remote management, right? If I go and say, well, virtual.tf, right? So all of those things, it gives light to the same thing. But when it comes to the standard of Terraform, right, we have to understand that the life cycle of Terraform dwells on what? The naming convention that we have to practice, meaning the main.tf file should always contain what? Your main configuration. But then in that main.tf, you can choose how your company respond, how your company assign naming, right, to represent that main.tf. But the standard practice will be what? main.tf. But again, you might not see it like that in every sector that you will work in or every sector that you will go, but it still carries the logic as if it is the main.tf file. Same as output.tf. Output.tf, people can use common.tf, common, common.tf, right? And then in variable.tf, people can use a different one too. And then people can also use what? Providers.tf, they can use what? A different name. but everything implies to what? The logic or the concept that that particular file is displaying. So to answer that question again, on a high level, that is the standard email. But then when it comes to what? Leveraging the file, especially on the professional level, when you start coding Terraform, you might not be using those things, right? You might be seeing it different. But then you cannot just see a code and then you determine what is in the code, right? You got to open the file. And then when you open that file, you say, okay, this is where this guy is, this is where they are declaring all the configuration in here. That thing happened. So let's say every day, I experience that every day on my job, right? I will open the file before I even know what the intent of that file is. But the contents of that file does not even give me the actual description of that file unless I open the file. Yeah, so that is very important for us to take into consideration.
So can we say that the .tf files is those files that contain the configuration of the infrastructure?
So the word .tf, anything that must be written in Terraform has to carry .tf. You understand? So you cannot write Terraform code without .tf, meaning it's not a Terraform code. But then what comes before the .tf, right?
Yeah.
Is a naming convention. Yes.
Okay.
You see the way we say, like if you look on my screen, you see
Yeah.
backend.tf, right? This backend stores what? Your Terraform remote state. But then I could say remote.tf, right? So when you open the file and see what is written in the file, then you understand why I named it remote.tf. You
Okay.
understand?
Yeah.
If you open this backend.tf and see the contents of the file, you will understand why I named it backend.tf. If you open this main.tf, or if I say actual.tf, the word actual, right? It gave a meaning. But then you cannot just assume what is in it until you open that file, right? And then you read. That's why as a Terraform engineer, you have to know how to read the code before you can say, okay, this is what this code is doing. So they have all of the main configuration saved in what? Actual.tf. That's how they keep it. That's the naming convention. You understand?
Yeah.
All right. So
just as Abe said, right? We only use those different names to do a description. So as an engineer and you building a code, you want to keep track on the different stages of your code development process. So you use those naming convention to describe what you're trying to do. So if another engineer comes from outside, that's why every time you're developing these codes, you also have to get documentations that when outsider come, they point to it. But with the naming convention, the standard naming convention also help another programmer or developer to easily, look for things and search for things through your code. So that's it.
exactly. And this is the main reason why if you go in every repo, right, there is something called readme.md or MB, right? You know why we create that file? By default, when you create a repo, you know why readme.mb come there? Because it's where you give detail about what that code is doing. You understand? If you are an engineer, you are not making use of the readme file, please start to make use of the readme right now. Because readme should define the detail of your code. You understand? So readme is very, very important. Do not ignore that one. Whenever you're having to create a code, to check in it in the repository, make sure you detail out what that code represents or what is it going to be doing. Okay. And I don't want the word code, right, for us to only take it for developer or programmers, right? Once we are engineer, you can write a code. What you see on my screen is a code. That code that you see on my screen is a Terraform code. If you wrote a script, you're writing a code. You understand? But that code is what? A bash script, right? If you're writing Python, you are coding. That code is a Python script. So all of those things, when you are an engineer, you code. People say, "Oh, is that thing?" I mean, many people can ask me if the boot camp involve coding. I laugh at them. I laugh. So that means when you involve coding, that mean it be part of it. No, coding is general, but what you do and what kind of coding you're doing matter, right? Yes. So that is for, we understand the backend.tf now. Now we in main.tf. Now, if you look at my main.tf file, right? Look at something here, what I did. I'm not just writing code. I'm writing it with description. You understand? If you look, the first thing I'm doing, if you look on line 2, right? And I'm going to copy everything here and put it in a different text, all because, I want to get rid of this. I'm about saving this. I don't want to save it. So I'm going to put this in here too. 5. All right. So if you look here, sometimes you got to design your code to look attractive, right? All of these things you see, they're not part of coding though. They're extra thing just to make your code. Oh yeah, The first thing I'm doing here, I'm performing data lookup. I'm telling you that this code, the piece of code you see here, it is looking up data. You know what this is doing while we perform data lookup? What is a data lookup in the first place? Can somebody tell me? When you're looking up data, what are you doing?
So you instructing the code, to go in the system and look for certain resources before they run.
Exactly, 100%, George. You are instructing this snippet of code to go in AWS and look up default VPC. You don't want to create it, right? You said go and find me the VPC and bring it to me. I mean, the function is a lot, right? But then the actual code is just a little thing. You understand? So if we were to go in AWS right now, guys, before you lay your hand on this project, I don't just want you to just do this project of doing the sake. You understand? I want you to understand every bit and pieces beyond what you're going to be doing. Because if you don't understand it, in myself, I feel like you have not learned anything. Because if you just go, I could trigger the pipeline right now. You see the beautiful stuff deploying, a lot of good things happening. But guess what? If you don't understand this thing, you are left out. So let us put our mind to this. Let me navigate to AWS for a second and show you something. VPC. So each availability zone in AWS gives you a default VPC. Do you see here? What you see here, guys? What do you see here?
Default VPC.
Good. Look at the code. What the code is saying here? Go and look for default VPC. Are you guys seeing that? So I am performing data and data instructing your code to look up. So I say AWS_. So my block type is considered to be what? Data, right? And then my block label is what? AWS VPC. And then my block name or another label, because there are two labels, right? Is also define the name of what they're going to look for, default. And then that's a default here is equal to 2 because I want you to use the tenancy of default. So default is equal to true. Whenever the curly bracket open, it has to close. You understand? So automatically, this guy will go in AWS and fetch that VPC and bring it. You understand? And then the next line say default subnet in that VPC, 1 per AZ. You understand? So I'm saying go back. There are subnets. Guys, go back to your networking, right? And those things will cover it. So go back in the VPC and get me subnet. Where do we create subnet, guys? Where do we create subnets?
VPC.
In the VPC, right? So we say go back in that VPC. That's why you see the code say default subnet in that VPC. So I said data lookup subnet in default. And then when you pass it with what? The VPC ID, because subnet comes from VPC. And then give me the value as what? Data AWS VPC underscore default underscore ID, because you're passing all of those values in there to fetch that details. And then perform filter, because we said you should grab it the availability zone, right? So default for AZ is what we call availability zones. And then the value should be set equal to true, because it has to it had to filter out the default availability zones. Are you guys having headache or you good? You doing good?
Yep.
Okay. Now, the next error say latest Ubuntu AMI. I'm telling you that data lookup to go there again. I said go and find me a latest AMI for Ubuntu 2024. And the owner should be what? I'm giving this owner this account number, which is RN, and then go and make it most recent. So most recent will be equal to true. And then filter it by name and give me the value as for Ubuntu image with the hard drive, the Ubuntu Noble, which is the version, and then the AMD 64. So if you're creating Ubuntu, you will know what I'm talking about. You create Ubuntu with these what? Keys, right? You do that when you're creating EC2s. So I'm passing this for it as a filter. And then the visualization tab, which is called the HVM, is set as a value. And then I'm using here, I'm finished now with data. I'm using local. So I'm using local now to get me my security group. And then I variable last this, and then I gave the instance name here, and a variable last here as per the project name. And then the name of the server, which is called web. Take it easy. You're not going to understand this right now, 100%. But give me your attention for a second. So we assign a common tag on this called mesh. We assign a common tag. And then we assign a name, and then we assign an environment, and then we assign a project, and then we assign the tag, and then we give it a tag. We variabilize the tags. That's what we call var.tag. Any place you see var means variables, okay? So we say var.tag, because we cannot hard code. I told you, the standard of Terraform, the lifecycle of Terraform is against you hard coding. Do not hard code. What do we mean by hard code? Hard code means I came in here, right? SG name, I didn't put in variable. I just say, well, I get a man name here. You understand? If you do that, you're exposing your system to hackers. Because hackers love to see something hard-coded. They can be happy. You understand? Yes. Any question? Then we scroll down. The security group. Who you know about security group? Everybody you know about security group, right? That security group you can see in AWS. This is how we call it. So security group now is a resources, meaning we're creating security group. We're not using data type anymore to look it up. We're creating it. Anytime you see resources, that means it's going to be created. You understand?
Okay.
So we say AWS security group. What's the name of the security group, guys? What's the name?
Web.
And then it's fetching from here. Local.sg_name. Description. Allow HTTP for 80 from the wall. SSH for 22 and allow SSH SADA. And then use the VPC ID to look up, from the data, because we use VPC today by data lookup, right? But then since we're creating the resources, we wanted to perform this because we already have our VPC. Because you cannot create security group outside of a VPC, can you?
No.
You cannot. So you have to call them again. You have to call it. It has to be called. And you have to pass it with what? An ID. Because that ID is the identity. You gotta tell me, what is the main key component of the VPC when you want to use it in code? Isn't that the ID you can use? So you pass it using the ID. And then the egress. So do you know what the egress means? Can somebody tell me?
Is the inbound?
It is the what?
The inbound, like the traffic coming in.
Yes.
Yes.
Inbound. It's called ingress. Those wasn't confusing, guys. Pay key attention to those things. Ingress means the inbound, or we say ingress means the traffic coming into the network. So we say description. What is the traffic description? It should be what?
HTTP.
HTTP. What is the port? It should come from which port? Port 80. And the protocol that it should come with should be what? Transmission Control Protocol, right? TCP.
Mm-hmm.
And then the SATA range has to be what? Open to the wall. That's why we say 0.0.0.0.0/0. We open it to the wall. And then we open the VPC, how you call the IPv6 traffic also to the wall as well. And then when you stop there, we give you another mode bound. We say allow SSH. Guys, if I remove allow SSH from here, you will never SSH into that server.
Mm-hmm.
I don't care what means you use. The same way, when you're creating a server, you can put SSH there. That's the same way we're doing it, but we're using code. This is what we call RAC, infrastructure as a code. So traffic is coming from port where 22, and traffic is going to what? Port 22. Protocol, TCP. SATA block, var.allow_SSH SATA. We go variable this now. Then I look at the egress. What is the egress?
Traffic going out.
Traffic going out. So traffic going out from 0 to 0. Any question? Now, if you see here again, we are using data. We are using data to be able to what? Get this security group web, and then the name here is what? The name that we choose to give it. And then we pass in using the VPC ID, because therefore, VPC, you form security group within the VPC. So we replace the reference here. So look at this. The next one on line 107 is resources. What is the first resource we created? I mean, the second resource we're creating here, EC2 instance, right? What is the name of the EC2 instance? Web. What is the AMI? It's here. What is the instance type? It's here. What is the subnet ID? It is here. What is the associated public IP? We set it to true, meaning when this get created, it will provision that public IP for us. You understand?
I'm a little bit confused. Not confused really, but out of the variable, out of the resources that we variabilize, it's being called out from the variable.tf file, right?
Mm-hmm.
Okay. Because we just go straight to main, so I was like,
We'll get to that point. We will get there. All the value you're seeing, they declare somewhere.
yeah.
They have been declared somewhere. So, VPC security group ID is here. After that, I'm going to recommend this. We're also going to get a public IP, the key pair name here. We're going to be passing this. In here, you won't see a value declared anywhere yet. This is coming directly from the GitLab CRCD pipeline. So you see the next thing I'm doing here? I say user data sh script should install Apache and place a placeholder index file. Your GitLab job then copy index file into this project and then run it. So I'm giving this little description here again. root_block device. This is just the hard drive of the VM we created, right? This is the volume size. So this is how we end min.tf. Just like that. Then we're going to go to variable.tf. So look at that. So variable.tf does. I gotta give you my way. So in here, variable.tf, look, guys. The first variable we declare, you've been seeing, I'm sure you've been seeing project name running around, right? So we declare a variable called project_name. Then we give it a description, which is what? The name prefix for tagging resources. And then the connection, the type is equal to a string. So string can be what? The combination of what? A letter and a number. And then validation, condition lengths, error messages. And the next variable is called what? As I'm sure you guys been seeing AWS US East 1 been running around, right? So this is where we're declaring it. Variable. AWS_region. Description. AWS region to deploy into. Type string. And the next one is our basic region format. See there? And then we go to compute setting. Variable. Instant type. Validation. Variable. Volume size. Validation. Variable. Allow SSH. Variable. Tag. You see there? Variable. The key pair name. So this is how we come to the end of the variable. That's how we declare them. We are configuring your Terraform system here to autocomplete. Let me tell you something that you need to take very, very seriously. Most of the code that is being written is not a code that we write from scratch. We analyze and get a code in our company repository, and then we clean up the code. Meaning we look at the code, clean up, say, yeah, we need to add some logic on the code, how to add some logic, and then we use the code. Because imagine you writing 1,000 lines of code from scratch, or 10,000, or like 500 lines of code from scratch. How much time it's going to take you? And then we move to providers.tf. You see what provider.tf look like? It just display a Terraform provider. Terraform require providers. Source is coming from HashiCorp. I told you yesterday that HashiCorp is responsible for Terraform, right? And then your version that you're using is this. And then your provider using is AWS. And then you see the README file. Yep. Any question?
What about the output.tf?
Oh, we didn't go for the output.tf. So output.tf, let me uncomment this. So output.tf file is one of the important files, but it's optional in Terraform. You understand? Output means all the value that we're going to be creating when you output it so that we can grab it upon runtime, upon completion. So in this case, we say output our DNS to us and output our public IP to us upon creation. And therefore, Terraform is going to output it to us. That's the only function of output. Yeah. That's the only function of output.
I got a question.
Yep.
So all the variable that we use in main.tf has to be declared in variable.tf.
Yes.
And if it's so, how do we call those variable in main.tf? How we do that one next?
So when you variable, you are using var.
Okay.
So let's say right here, right? I'm going to forget about this code for a minute. I'm going to do this from scratch, okay? Let's do this from scratch. I say provider. Let me enter a few steps down. Go. So provider will be equal to so who can tell me what am I doing on that screen?
Declaring?
You are declaring the variable AWS. Provider, please.
Yeah, you say I'm declaring, right? Yes, I am declaring. So on this, I say region equal var dot AWS _ region. All right. And then on A, I say AWS _ access underscore key underscore ID equal var dot AWS. I just auto completed it. All right. AWS underscore secret.
Sure.
Oh, sorry. Underscore access underscore secret underscore key equal AWS access secret. Now, I don't want to do this in this window, right? I don't want you to get confused by the by the plenty text that I see here, right? Let me look for somewhere. Let me open a new window for you all. Guys, I want for you to understand Terraform like a baby. All right? I'm sure we're going to do that, right? We're going to understand Terraform like a baby. Terraform can make people afraid, though. And nobody should be afraid of Terraform. So, I'm just creating something. Yes. I love the working directory, okay? So I said Tosh, and I'm creating providers. Providers.tf, right? I created providers. And then I hold down my shift and just open it so I can see, so you guys can see the provider. You see the file I just created called provider here? Now the code I created today, I can paste that code in here. Do you see this? So I paste the code in there. Now, you observe that you will see a red line running under them, right? It's an error line. You know why it's saying it's an error line?
Yeah.
Why?
Because we just declared a provider, but we haven't called it yet. There's nowhere in your code that it's pointing to. So it's like an error till you point it to something.
Okay. Makes sense. So I create a new file. Actually, I won't create a file from here anymore because the thing is getting a little annoying. I create a new file. I'll create a file. Okay. I'll create a file here. I'll bash in here and then create a file here and say Tosh variable .tf, right? Automatically you see the variable come here, right? You see that? So I say variable. So I click on this variable and I say what? AWS underscore region, right? And I declare the variable.
Yep.
And then which region am I declaring here? US.
It's two or it's one. It could be,
One. And then AWS underscore region. And then I get a description. This has to be provision right here. US East 1. So you see, what you observe, right? If I go back to provider.tf, you will never see red line on the regions anymore. You see red line on the region, it went away.
So
And
now
if I
it's
went,
pointing to something.
yeah, so if I went back and I enter 2 times, and I say variable, you see, even as I'm saying variable, you see it giving me the access key because I know that the next thing I can create, right? if I just enter here, right, and create a string, you see here, I have defined this access key. And then I scroll another variable. VARIA variable. Oh, this. Why is this coming up like that? Okay. So variables, no variables. So I put a variable here and I declare the secret key for that. So what do you see here, guys? There's a red line still on it. You know why? You know why? Emmanuel, your hand is up.
Yeah, quick question.
Yep.
Looking at the variable file, wherein we define objects in the variable file, is it a good idea to have our variable files before we have our our produce file?
Provider file.
Yeah, the provider file. Is it a good idea? Because we noticed that in our provider file, we were saying something like there were errors, which of course they were not error because they were not defined. So since we defined it in variable file, notice that the red line that was under AWS got removed because it could identify that, oh, I have been defined here, so there's no error. So is it a good idea to always have the variable file first, where we can put all of those things, we define all of them before we start like moving to other files that will be calling them out from that variable file?
So to answer the question, you can write any file right after the other, right? Terraform does not restrict anyone that you want to create. But for best practice, always write your provider file first before your variables. You know why? Because you don't know what you're declaring, right? So how will you write variable when your resource is not yet, put up? You won't know. The reason why I intentionally designed this so that you can see that if you create or declare a provider, right? Note that the reason why this all failed, guys, because we are using var. We are telling this that variable exists when at that time there was no variables. You understand? So the best practice is write your main.tf first before your variables, because it's from the configuration that you determine how to create the variables for it. You understand? You cannot create variables when you don't know what configurations that is being defined there. So the best practice is create your providers first before you create the variables for providers. Create your main.tf first before you create a variable for main.tf. Create your output first if there's a name for output variables before you do your variables. That is the best practice. But Terraform does not distinguish, right? You can write variable before you start writing main. Terraform will put it in the way that it should be whenever it comes to provisioning. But the best practice, the standard that will make your life easier is what I'm saying right now. Write your providers. Like take for instance, right? Let me just tell you something. Like take for instance, we have this providers. We're still seeing this red line. You know why we're seeing this red line? Can somebody tell me why we're still seeing this line?
I think in line 6, we are missing var after the equal sign, we miss var dot.
Yeah, I will still put a var. Yeah, that's a good point to write. You catch that point. But still, there'll be a red line.
I think because they are not defined.
Yes,
They
my
are
brother.
not defined, yeah.
Because they are not being defined. Remember, where is this getting the value from in the first place? So that brings us to a file called Terraform.tf vars, where we say region. Let me look at the configuration. Now you see why it's important for you to have your configuration before variable, because you don't even know how to define it. If you don't have your configuration, you won't know how to create the variables for it. So if I went in here and look at variable, right? Okay, regions, right? So in the TF var, we say what? Region equal US is 1. And I say AWS, sorry. Oh boy. Access, key, ID equal your access key. So my access key here, I can put, if I put anything here, AWS will take it as an access key. I want to tell you some real-time stuff right now to know something for this. And then I come here, I say AWS, access, secret, key. And then give me this. It's indented 8. That's fine. Now, there comes this. Access secure key. Let me carry this up. So we solved this problem. I want you to point to this, right? You see here? What is Terraform saying here? If you point to this.
An attribute name AWS on is not expected here.
And then the next one, it says the same, right?
Yeah.
Okay. So if we did Terraform, validate. What you see? It cannot validate it because it don't even know that this is a Terraform file yet until you can run Terraform in it. Guys, I want you guys to think back and think when we're going through Terraform, the configuration, the life cycle, why we run Terraform in it, why we run Terraform plan, why we run Terraform apply. Everything that we just write here, we wrote it as Terraform, but our working directory has not been established that this has a Terraform configuration. So the first thing, after you even write this, that you do is what? Terraform init. Look at what it's doing. It's initializing the Terraform providers. It's downloading that plugins. Once this download, it will register up there. You will see what we call .terraform will come. That means your provider are being initialized. Can somebody tell me what messages you are getting?
It's already been initialized.
It already been initialized. But then, according to Terraform, it says do not put access key in here. That does not mean that we can put it there. We can put it there. You understand? That does not mean that we can put it there. We can still put it here and it will work. Because what Terraform is expecting in here for us to say, well, profile. And then we say default. But we say no, we are not enterprise yet. We won't start it for the basic. We declare yet. But what Terraform is looking at, I know that this configuration is local. So it wants us, instead of doing that, for us to be able to say AWS configure. You see here, AWS access key should be declared right here. AWS secret key should be declared right here. You see here? And the AWS region should be what? US East.1. Output should be none. You see there? So in note that we should be declaring it as a what? Environmental variable. You understand? Because this is not being consumed through the pipeline. When we consume these things through pipeline, we don't put these things in here. So Terraform know that because we are not doing this, so we don't need to put that in there. So we want to make sure that, okay, since indeed we have this defined in our environment variable, everybody go to your console and tap the AWS configure. It will give you this option to put your access key, your secret key, and your default region and everything. If it don't do it for you, that means you don't have AWS CRCD installed on your system. Meaning you cannot talk to AWS. That means there is something wrong with your system. That means we have to configure it for you to talk to AWS. But before then, we take this thing from here. So technically, a question to the class though, do we still need the TS vars here? If we already have the value that we need and we pass it as an environment variable, do we still need the TS vars?
I would say no.
Anybody want to argue that, or anybody have something to add on it? We do not, because the purpose for which we needed the TS var is gone. So providers come here, and then technically we do not declare this because our access key has already been what? Provision. We don't need that. Regions, we have variable for region. But this access key and secret key, they become optional now as a variable because we don't need them. You understand? We don't need them, so they become optional. But if our original code that we're going to be using, we do need them because we are passing this in our CRCD variables. But for the sake of just declaring the provider, we don't need this. I didn't close this when I open it. Everybody close it. You understand? So in here, if we did Terraform init, it will initialize, and then it will download this provider plugin just by AWS. Terraform will know that this is AWS provider that you're about to deploy to, so it's going to go in there and what? Create a plugin for AWS. And then we'll tell you that Terraform has successfully initialized. You may now begin working with Terraform. Try running Terraform plan to see. It's telling you now what to do. Because you have initialized, now you have made this directory to look like your Terraform directory. So if you do Terraform plan, of course, what are you planning? Right? What are you planning? Are you just planning providers? Do you have anything other than provider that you are going to plan? You see it? Look at this is why it's because you left it in here. This is why it's asking you for the value. You understand? Because you left them in there. That's why it's asking you for the values. I intentionally fill it, and I'm going to do this. I'm going to go back to variables and take this out. Take them from there. Clear my screen. And I do Terraform play again. Look at what it says there. Your infrastructure matches their configuration. Terraform has compared your real infrastructure against your configuration and found no different. So no changes are needed. It's because, guys, you don't have any freaking resources to run Terraform play against. You only run Terraform play against providers. That's all. So Terraform is very, very robust. So the code that we have written in here, let's go back to our code. The code that we have written in here. Now, in this code, I'm going to go in here. And do a git status. I'm going to do a git add. I'm going to do a git commit. I'll just say update there. I won't put a lot of stuff there. I won't do a git push because I want to show you guys the GitLab.cr. We are read through everything, but we did not finish the GitLab.cr, right? So I want to show you the GitLab.cr. This will intentionally fail the pipeline, and I know the reason for which I'm doing this because I want us to debug. So GitLab.cr file. This is the file that giving birth to everything that you see in there. The first thing the file is doing is running this HashiCorp 1.13.1. If you look at this version, it looks similar, right? Remember yesterday when you were installing Terraform, what version did you use?
It's the same. 1.1.
It's the same, right? Exactly. So we are using this now as to run in a Docker container as an image. You see what we put image up here? And then we say the stage. These are the stages that I want my pipeline to be built in. So I say it should first do the validation state. It should do the plan. It should do the apply, and it should do the destroy. And then it should pass these input, these variables. And then it should set the commit.ts var path or leave it empty to skip. You can give it the option. And I say run every job to keep commands as simple, default, Terraform version. So it will dig down in the path to ensure that Terraform is even installed, that all the configuration profile are set before you can even start running the Terraform. And then I say the validate state will validate Terraform that your configuration is okay. Then the plan state will plan your infrastructure as how it will look when you get provision. And then the apply state happen with manual intervention. Do you know why we don't do apply as automatic? Because you have to review your plan before you can apply. So it cannot be automated. We cannot do it automatic. Okay? Because you have to review pull requests, right? Before you apply. That's why we cannot do it automatic. Are you getting it? Because pull request has to be reviewed. So destroy is also manual. You have to be certified with your plan before you destroy. Please understand that. Okay? Now, in this now, this is our GitLab file. This is our CRCD file. I'm going to go in here and push. I'm gonna go in and push. And when I push, so I'll say git push origin. So before I push, right, I want to do something though. I want to create a branch out of this branch. So I say git checkout. What's the command to create a branch, guys?
B.
Thank you. Petra slash email suggests a name. What name should we give to this?
Terra.
Just that? Just that email?
Image I want Terra.
That's the branch, right? Yeah.
Yeah, I was just making sure that's what you want.
Yeah.
All right. So we created that branch. I do git status. Change this committer. So I do a git push origin feature error. The push to it, right? So I go now to our barbar, GitLab, and then select this project. There's a project that we all agree to work on, right? And then I select build, and I go to pipeline. I know that pipeline will fail for one focus, but our focus should not be on the fill yet. Our focus should be what is happening. So guys, look at this. This is our pipeline here. This pipeline, it just filled 14 seconds, 16 seconds ago, right? So I click on the fill one. Look at what you're going to see here. The GitLab.cr file show you. You see how you build your pipeline? Look here. You're going to validate that the part I was showing you in a code today, that's what it has built. In this, it has architected this like this. A very plain and a very formatted way for you to view your infrastructure. So validate, plan, apply, and deploy. Frankie, when you look at this, you think about something, right?
Yep. Yep.
Good. So when I click to know where we now went, for you to know what went wrong, you have to click on your field job. So you click on the field job, and then you ask yourself, what went wrong, right? What went wrong? Look at that. Look at that. You see that? Can one student put a hand up to debug this for us and fix the code so that the pipeline can run? Because this is all about Terraform. You see what we call debugging now? So should I give this to the class to figure that out next week and make sure the code is fixed?
Yeah.
Yeah.
Or should we fix it now?
We can look
That
at
should
the
be our assignment.
moving the code too fast.
Like give it to them, let them look at the error messages and see if they can come up with the solution. It's a
Let me
nice
see.
assignment there.
Let's go to line 99 because the error is saying more point to 99 from. It got a couple of lines.
Nah. My
Yeah,
trial can catch somebody because I said something yesterday about what Terraform can do with error. So somebody coming fall in that trap. Yeah, nah. What you say about it?
no, I was looking at something. It was pointing to 99. That's good. Let's go back to the start of the error. I want to see what.
You know what? You know what I'm gonna do, right? You know what I'm gonna do? I'm gonna fix 47. You understand? I'll fix 47. And then based on the fix, you're going to determine how the rest is going to be fixed.
Unresponsive block.
So for the 7, say unsupported block type. Do you listen to that English? Unsupported block type.
I mean that the data in there is not supported by either Terraform or.
So good, right? Those are all suggestions. So let's go to the code. Let's go to the code. The code is right here, right? And where it outline, it say, eh. So which file you say it was in? Where the error coming from?
Me.
Thank you. So go to me. Line 47, right? George? Hey, we're going to line 47. Do you see anything on how to do a block type for line 47? Do not take into consideration the line number. Okay? Terraform will fool you. So go to your core, investigate. You see right here? You see here? Unsupported block type. So meaning this is not a core, guy. This is not a core. So it should be
Hashtag before it.
hash.
You have to uncomment, yeah.
A hash. See that?
Okay.
Let's push that core again and see if we'll get that error. So let me clear my screen. So I say git add git commit updated git push origin feature Terra. And then let's go to the bar bar. Let's go back to the pipeline and see what the pipeline say. So the pipeline is running, right? So the pipeline runs. The first stage are running here. The validate state, but it still fail because I know it will fail, and we all know that it's going to fail. Did anybody know that it's going to be successful?
No.
Okay.
No,
Good.
there's too many errors in there.
Exactly. So we go here, and then we want to see what went wrong. So let's look for the error that we're pointing to today. So do you see that error that we're pointing to anymore?
No.
Because we fixed it. But now it says unsupported block type on what? Line 22, latest Bluetooth. Latest Ubuntu. Do not focus on line 22, focus on what? This was I giving to you. So let's go back. It's still on the mean, right? You see here? What we need to do.
We need to comment that latest Ubuntu. Hashtag.
Remember, I said some things here will be done intentionally so that you can debug. That's a simple one here. So I'm going to debug everything here because you guys have grabbed the concept now. I'm going to debug. I know, Fred, you don't want me to debug this, but you want me to give it to you guys as a project. But we'll debug this for now because I know the hard one that will come. And you'll go fix that one. So let's debug this. All right, so we debug. And then we go to output. Then we go to providers. Then we go to variables. Some positive variables, but that's okay. All right, so can we push our code again? Right? Let's push our code. Git add, git commit, git push. So let's go back to the bar bar and go to our pipeline. Now, if you understand anything, the job will be waiting for you right at your door. The pipeline is running, right? Hands up, who know that this is going to fail again? You put your hand up now. So when your Terraform code is running, you can also look at what step is it executing. Wow. Oh, you see that? It passed, right? Boom. You see it? So your pipeline was successful on this state. But guess what? Your plan trigger automatically. You see here? The plan has triggered automatically. Did we trigger the plan? No. After the validate, it went and triggered the plan. Let's see our plan. Look at that, guys. See how beautiful this thing is, man. You see here? This is telling you how your infrastructure will be when you get provision. These are all of the resources that will be created. Do you see here? Look at that. You see? See resource owner? All of these things. So you 2 to add, 0 to change, and 0 to destroy. This is what you should be looking for. I know my dear friend here, Frankie will be saying, yeah, he want to call somebody named called Dan Perry here. But that person name has to wait. So if you look here, right, this is all you need to read. Is this the actual thing that you expect? Yes, that's the actual thing because we are creating technically 2 resources. Who can argue that? I want us to argue this. Is it true we are creating only 2 resources?
Yes, because from the code, I know that we're creating a EC2 instance.
Thank you, Georgie. Thank you so much for that. I love that, man. You scanned the code and you knew that we were creating just 2 resources. Data lookup is not a resources we were creating. We were fetching, right? But you scanned the code and then you said that this particular main.tf is only giving birth to what? 2 resources, right? And what are the 2 resources? Resource number 1 is what? Web. Resource number 2 is what?
VPC web.
Security group. VPC is not creating VPC, it's fetching VPC by using data lookup, remember. All right? So let's go back to our bar board and say, okay, we are certified with this now. Let us proceed now and deploy. And we're all certified with that. Now, that's what we wanted to see, right? So to deploy is manual because you have to, because if this were to trigger automatically, will you know? No, right? And then there will be a problem. Because pull request view has to happen, merge request has to happen before we can deploy. So we click here and say what? Apply, then we'll play the button. We play that little radio. And then guess what? They're going to be panning, and then the agent feeling picking up the job. Look at what's happening. This agent has picked up the job and is running the job. Wow. Something happened. It did not apply because it says something happened. Who can tell me what happened? Can somebody debug this in 2 minutes? I mean, in 2 seconds, not even 2 minutes.
Yeah, I think a security group, the name already exists for VPC.
Exactly. That name already exists. So that's why it did not create it, right? So because it already exists. You understand? That name already exists. So what we will need to do is what? We need to destroy that particular security group, right? we need to destroy that security group. So guess what's going to happen? Go to our Terraform code. What's the security group here? I put a web 1, right? No. I'm not going to modify it right now. I'm going to destroy it. So to destroy, you either delete this from there and run the Terraform, or you highlight from security group. Yeah, guys. You highlight it here. And then you highlight it right here. You comment it out. You comment it out. And then you run your pipeline. Guess what's going to happen? We will all see it. Did I do git commit? No. Let's see if our pipeline will validate. If there's a variable for variable group and we didn't comment it out, it will yell at us. But let's see. You see here? Look at the pass, right? Let's see the plan. So the plan executed, but I didn't like the plan I execute because I supposed to see it tell me that no change. And wherein I know that there's a change. So let me see my apply state. Oh, you're expecting me to completely destroy that resource. God, give me 1 second. So you see, it went ahead and applied. All right. Because we commented out that resources. So it did not provision that resource again. Yes, it is correct. You see that? Now, for those of you that said, what is the output command doing? Look at that. You see what output gave to us? Our URL, right? So when we click on this, we can technically see our deployment. Look at that. You see up here? What do you expect there? Welcome, your deployment works. Guys, this is what we call E to E, all right? The concept that you understand that you're grabbing here right now, it can make you to do anything in Terraform. It can make you to push any code. It can make you to modify any changes. It can make you to make decisions. Any question?
Yeah, quick question.
Yep.
How did we generate this getting started? Is it default? And where you say welcome, your deployment work, where did we which part of
Yes, sir.
we added those ones?
Yes, sir. So look at your code. You see user data.sh. You see what is running in it? You see here?
Okay, I didn't see this first. Now I see it.
Yeah.
It's when this HTML code.
Exactly. So this is why we are able to see this.
And another question is looking at these different files, we have main, backend. How are they linked? I'm seeing one variable is calling another. How is that working? How does it know another file? How does it know something in another file? Because I don't see the link that connects the both of them. How is it working?
There is a link, and that link is called Terraform configuration. That's the power of Terraform. When we write a code in Terraform, we declare, all right? We declare. And when we declare, it calls that resources that we declared it. That's why in Terraform, when we deep dive into Terraform, right? Your Terraform codes, you understand what we call idempotent or idempotent, right? That is the power of Terraform. So Terraform is idempotent, meaning the desired state of Terraform is always matched with your current state. And Terraform uses a declarative approach that you declare and reference and call all the variables inside of Terraform. And Terraform will go and loop into it, right? Remember, when you asked me the question, is it a best practice for us to create variable.tf first before we do this one, right? What did I say? I said, no, but Terraform does not judge, right? Either one comes first, Terraform will loop into them because the configuration of Terraform says declaration. So you declare and make sure your declaration is indented properly. That's what Terraform is looking for. If it did not, Terraform will yell at you and tell you, no, you got to go fix your stuff. So the reason why all of these things are calling each other, because if you read the code carefully, I'm going to give the code to every one of you, right? You will take your time. The concept I have given to you, you go take your time and read the code. You will know that you see this script here, which is our actual code. The reason I did not call this out because I told you this, right? Do not focus too much on the code aspect, on that website aspect, right? On what is getting provision. Focus on your job here as a DevOps on the cloud. So if you look at this code, right, Emmanuel, you would know that this code is linked to that configuration you see over there. So yeah, you see what the code is doing? This code is looping into the server now that that Terraform is provisioning. And then you see the good part about it, it does not care if that server has been provisioned. It already trusts Terraform that Terraform will go and provision because the work of Terraform is what? To provision infrastructure, right? So this code will go into there and install Apache web server there for you. You see that? And then it runs the systemctl to start Apache. And then it take this from the temp file, this file here, and then it create this folder and take the contents from here, which is this content, and then it put it in to this folder. And this is how you are able to view that on the web. And then it give you your endpoint for it. So everything in here is linked. But the how you call it, but the link aspect of it is the power of Terraform. It's the power of automation. All right. The same way when you're writing a bash script, when you call a variable and then you loop between functions, you go and get the values. That's the same thing we are doing in here. So this is the power of Terraform. And then if you look in your GitLab, right? The question I expected most of you to ask is, if you look at your GitLab here, you see the stages, you see the describe, you see the apply. We only code these things, but guess what happening in GitLab? In GitLab today, it is getting designed very, very neatly. So look at what's happening. They apply, they plan, they describe. Look at how neatly this get designed. Look at your pipeline. Just look at your pipeline structure. Let me click on this so you can see your pipeline structure. It is black right now because we didn't destroy it yet. Okay, look at pipeline structure. You see here? Validate. We just code these, right? We did not come here and create this line. Did we create all of these lines here? No. We just code them. And then it gave us this. Validate, plan, apply. So right now, this is destroy. If you play destroy, which we're not going to do right now, it's going to go there and destroy it. And destroy our resources. But let's go in AWS first and verify if our resources are actually got created. EC2 dashboard. Do instant running. Look at that, guys. You see it? You see that IP that our website running on? It gave us this. So to make sure that this is the VM that got created, right? We can also look at the timestamp, okay? We can look at the timestamp in here and know. But to know that this is the VM that got created, I just take this endpoint and put it in here and hit enter. This is not a VM that got created. This is the actual code that I deploy, and this will be our next project. This is running like a banking system. You go to the bank to make deposit. It gives you a value, it calculates stuff. But if we go back to the EC2 instance, let's look at the second one, right? And we'll copy the endpoint, which is the IP, and we'll put it in here. So ladies and gentlemen, this is what we deploy, right? So our VM actually got created with the resources. Any question before we take our leave? Expect
I have a
next,
question.
Yeah.
So the variables.tf file, if you create that file, Terraform automatically know that he will use that file to fetch the variable that he needs.
Yes.
Okay.
Absolutely. Yes. Yes. Yes, yes, brother. So next week, when we get in class, we're going to be doing interview, question and answers for what we have covered so far. And then we're going to start from there and move on to our, with our project, understanding our project again. So I'm going to be asking you some question and answers, DevOps engineering, cloud, all those stuff. So make sure you do your practice, all those things. And then your server will be power on. So please, you can go in there, and be able to do your practice on your server. Okay. So guys, that's it. That's what I have for you guys today.
All right, thank you so much for today.
Yeah, thank you so much. We'll go back and review the video.
All right. Thank you guys. I'll see you when I see you.
All right.
Okay. All right, guys.
When are we seeing this video? Today's
tomorrow.
All right, thank you.
Okay.
All right, guys. Thanks. See ya.
Yep.
Thank you.